Okay, this is the last part of section 5-6. It's about rotations. That's the last type of transformation. So another word for rotation is a spin. Okay, and every rotation has a fixed point that we rotate it about. So if we were to take an object, like for example, let's say I just take this pack of gum, okay, and I were to place it here, and I were to pick the center as the point of rotation, and I were to turn it 180 degrees, which is halfway around, it would end up looking like this. Okay, now if I were to pick, for example, this corner and rotate it 180 degrees, it would end up in a different location, right? So just so that we're aware, today we're only going to be dealing with rotations where the center is going to be at the origin. So we're not going to worry about the different points of the center of the rotation. Okay, so we have rules just like we did for reflections. And the rules are, first of all, a 90-degree rotation. By the way, there are two different ways that we can turn. We can turn clockwise, which of course is going this way, and we can go counterclockwise. Now, when I say 90, 180, 270, 360, those are all going to be counterclockwise. And the reason is that in math, counterclockwise is the default direction. Just like when we name the quadrants, we start up here and then we number them counterclockwise, 1, 2, 3, 4. So this is going to be the same exact thing. So when I say a 90-degree rotation, that means it's going to take something from quadrant 1 and rotate it into quadrant 2 because that's counterclockwise. Okay, so the rules for these, again, you know, you're not going to have to memorize any of these, but what a 90-degree rotation does is it takes, first of all, the opposite of the y coordinate and then the x coordinate. Okay, a 180 rotation is going to take the opposite of both the x and the y. Okay, because a 180 rotation will get you over here, which is like a y-axis reflection and an x-axis reflection. So it kind of combines both of those rules. Okay, a 270 is going to be the y coordinate and then the opposite of the x coordinate. And a 360 just gets you all the way back. Okay, so we're not really going to do those, but just know that a 360 is just going to be exactly where you started. Okay, so I apologize if you have the notes packet that I forgot to change these words. So we're going to graph the image of this triangle after a 270-degree counterclockwise rotation about the origin. Okay, so the first thing we're going to do is write out the coordinates. So A is at the point 2, 6. B is at the point 7, 3. And C is at 1, 3. Okay, so a 270 rotation, we're going to apply this rule right here, which is we're going to write the y coordinate and then the opposite of the x coordinate. Okay? All right, so A prime. So the first thing is we write down the y coordinate, which in this case, the y coordinate is 6. And then we're going to write the opposite of the x. So the x coordinate is 2. The opposite of that would be a negative 2. Okay, we're going to do that with b to b prime as well. So the y coordinate for b is 3. And then the x is 7. So we're going to take the opposite of that, and that would be a negative 7. And then finally c prime, using our rule, we start with the y coordinate, which is 3. And then we write the opposite of the x coordinate, which is going to be a negative 1. Okay, so let's go ahead and graph these. 3, 4, 5, 6. Negative 2 is going to be here. That's our A prime. Our B prime is at 3, negative 7. And our C prime is at 3, negative 1. Okay, so what actually happens then is this got rotated 270 degrees. This and this figure are both congruent. They're the exact same shape and size. But notice every quadrant is like 90 degrees. So if I go counterclockwise, this would be 90, 180, 270. So this landed in the correct spot. Okay, another thing to kind of notice is what happens is if I were to connect an original point to the center of rotation, which is the origin, and then connect it to its image, okay, what I end up getting is a segment that's the same exact length. So this length and this length are the same. And notice that I have a right angle here. Okay, that's a 90-degree angle because going 90 degrees this way is the same as going 270 degrees this way. Okay, and that would be the same for any points. If I were to connect A to the origin and then to A prime, I would also have a 90-degree angle there. Okay, so this part says write the coordinates of A, which is at 4, -3 after a rotation, first of all, 90 degrees about the origin. So if it doesn't say counterclockwise, we're going to assume it means counterclockwise. So with this one, the rules for 90 degrees is opposite of y and then the x. Okay, so for A prime, if I look at the y coordinate first and I take the opposite, the y coordinate is -3. So the opposite of that would be +3. And then we just write the x coordinate down, which is 4. Okay, a 180, the rule for 180 is the opposite of x followed by the opposite of y. So A prime, opposite of 4, the x coordinate, would be a -4. And then the opposite of the y is -3, so the opposite of that would be +3. Okay, and then a 270 rotation, our rule is y and then opposite of x. So if we applied that rule, we start with the y coordinate, which was -3, and then we write the opposite of the x coordinate, and the x was 4, so we're going to write that as a -4. Okay, so that's how you use the rule. So with rotations, graphing it is not going to be as easy as reflections. It's just figuring it out on the graph. So I recommend that you use the rules every time. Okay, so when we do this, we're doing a 90-degree rotation, and the rule for a 90-degree counterclockwise rotation is the opposite of y and then the x. So here it's saying multiply the y coordinate of each vertex by -1, and then we're switching the x and the y coordinates around is basically what's happening. Okay, I'm not going to try to apply that rule here. I'm just going to use this to write my coordinates. So let's start with the coordinates of A. So the coordinates of A are originally at 4, 4. B is at 4, 1. And C is at 2, 1. Okay, so now I'm going to apply this rule. So starting with the y coordinate, this one is 4, so the opposite of that would be a -4. And then we write the x coordinate, which is 4. Okay, the next one, again, start with the opposite of the y, and the y is 1, so the opposite of +1 is a -1. And then we write the x coordinate, which is 4. And then for the last one, again, start with the opposite of the y. The y is +1, so the opposite of that would be -1. And then the x coordinate is 2. Okay, so let's go ahead and graph that. -4, +4, that's our A prime. Make sure you are labeling all of your points correctly as you plot them. This is B prime, and then C prime is -1, 2. Okay, so there we have it. This looks congruent to the original figure, which it should be, and a 90-degree counterclockwise rotation means it goes one quadrant over. So that's what happened here. Okay, and here's one that is a 180 rotation. So 180 rotation, the rule is the opposite of the x and the opposite of the y. So let's go ahead and write the coordinates here. So the original one is x is at -1, +2. Y is at +2, +3. And z is at 3, 0. And I strongly suggest that you write out the coordinates and then write out the coordinates of the image afterwards. Okay, so for 180, 180 is pretty easy. All we do is write the opposite of both coordinates. So the opposite of -1 is +1, and the opposite of +2 is -2. Whoops, that should be called x prime. All right, y prime, the opposite of 2 is a -2, and the opposite of 3 is a -3. And then z prime, the opposite of 3 is -3. The opposite of 0 is just 0. Okay, so that one is a little tricky because 0 is not negative nor positive. So we just keep it the same. All right, so x prime is at 1, -2. Y prime is at -2, -3. And z prime is at -3, 0. Okay, and again, this should look congruent to the original figure, which it does. And if you look at each point, x did actually go 2 quadrants over because it's 180. So this would be 90, and then 180 would land it here. Y is in the first quadrant, so if I moved that 2 quadrants because of the 180, y would be 90 here and 180 in this quadrant, and then z, since it's on the x-axis, it's going to stay on the x-axis because 180 degrees would land you over here. Okay, please let me know if you have any questions about the rules for rotations.